Hello, in this video I'll try to explain interfacing of 7 segment display to LPC1768 microcontroller to display the hexa digits 0 to F. 7 segment display is an array of LEDs arranged in rectangular fashion which is used to display decimal number and hexadecimal number. The 7 segment display is available in two forms. The one is common anode and other one is common cathode. In common anode, all the anode terminal of LED is shorted and connected to VCC, whereas cathode terminal is left open. Suppose if you want to lit a particular segment of the display, then the corresponding cathode terminal of the LED should be grounded. And similarly, in case of common cathode type of display, all the cathode terminals of the LED is shorted and connected to ground. And if you want to lit a particular segment of the display, then the corresponding position or corresponding anode terminal of the LED should be connected to VCC. I means you have to send logic 1 to the corresponding anode terminal of the LED. So this is how the 7 segment display will be working. In perspective of lab, let us look into the schematic. So in a kit there are 4 7 segment displays are available. They are named as U8, U9, U10 and U11, which is not shown in this slide. Okay. And let us consider U8. So U8, there are 8 LEDs, that means 8 segments including dot point. So segment A, B, C, D, E, F, G and the dot point. Along with that, a common cathode terminal which is CC and CC1, which is connected to star enable 1. So this LT543 7 segment display is common cathode type of 7 segment display. Suppose if you want to lit a particular LED segment, then you have to send logic 1 to the terminals which is specific, that means to a particular terminal. So these segments are in turn from the output of a tri-state buffer. So we are using 74HCT244. It is a tri-state buffer. This buffer can be used as 4-line buffer or 8-line buffer. So in this schematic, which is used as 8-line buffer, because both the 1G and 2G are activated. Okay, so they are active enable pins or active low enable pins, both are activated. So this is used as 8-line buffer. So the segment A, B, C, D, E, F, G of a 7 segment display is from the inputs of a buffer segment 0 to segment 7. So if you send segment 0 to segment 7 logic 1 to any particular line of this segment 0 to segment 7, the corresponding segment A to segment D will be activated. In turn, this segment 0 to segment 7 are connected to connector A2, okay, in the kit. So that is pin number 1 connected to segment 0, 2 connected to segment 1, like that. Segment 0 to segment 7 consecutively connected to pin number 1 to pin number 8. From the microcontroller side, the connector A, pin number 1 to pin number 8, in turn connected to the 4th, 5th, 6th, 7th, 8th and 9th pin of port 0. Therefore, the 4th, 5th, 6th, 7, 8, 9 and 10 and 11th pin of port 0 is in turn connected to segments of the LED. Okay, so these port pins are used to send a proper value to display a hexadecimal number. And there are 4 display units array, as I told earlier, that is U8, U9, U10 and U11. You have to choose any one among these 4. In order to choose that, you have to activate this enable line. So in turn, this enable line are connected to the output of the decoder. Here we are using 74LS145, which is a BCD to decimal decoder. So the 4 enable lines of each display unit are named as star enable 1, star enable 2, star enable 3 and star enable 4. They are connected to the output of the decoder. So you have to in order to activate any one display, you need to force a proper value for this decoder input. Okay, let us look into the first we look at the pin numbers, then we look into the values that are supposed to be forced to this decoder to select any one among the 4. Okay, so in turn this enable 1, 2, 3, 4 are connected to connector B. that is 1, 2, 3, 4 of the connector B is connected to enable 1, 2, 3, 4, that is the input of the decoder. Now at the microcontroller side, connector B, pin number 1, 2, 3, 4 is corresponds to 23rd, 24th, 25th and 26th pin of port 1. Therefore, the 23rd, 24th, 25th and 26th pin of port 1 is used to select any one among the 4 display. Okay. Now let us look into the values that supposed to be write via FIO pin register to select a particular display among the 4. So since we are using a BCD2 decimal encoder and the output of the encoder is active low, that means if you give 0, 0, 0, 0 as an input, then the 0th line of the output will be activated. That means the output across the 0th line becomes 0, whereas rest of the output line becomes 1. And look into the output, enable 1, 2, 3, 4 that is, are connected to the 0th line, first line, second line and third line of the output of the decoder. Suppose if you want to select the first display, then you have to force the value as 0, 0, 0 and 0. That means the port 26th port, 25th port, 26th pin, 25th pin, 24th pin and 23rd pin should be 0, 0, 0. So if you provide this value, then the corresponding 0th line of the decoder will be getting activated, then it becomes 0, whereas rest of the pins, output pins will become 1. So in turn you are going to select the first display unit to display the number. Okay, so in register this value, corresponding values like this, that means 23rd position, 4th, 5th and 6th position should be 0 and remaining all position of the FIO pin register will be selected as 1. In that case the corresponding hexadecimal value is F8, 7, okay, this is F8, 7, F. Okay, so this hexadecimal value is need to write via FIO pin register to select the first display. Similarly, if you want to select the second display, then the corresponding input must be 0, 0, 0 and 1. Okay, thereby the first line of the decoder output will be getting activated and this particular output becomes 0. In turn you are going to activate the second display in the kit. So in order to activate the second display, so the corresponding position value in the register is, that is the 23rd position should be 1 and remaining 24th, 25th and 26th position should be 0 and remaining register positions must be 1, 1. So the corresponding value is F and this is 8 and again this becomes F, okay, and F. So this is 0x F8 FF is the value should be write via FIO pin register to select the display 2. Similarly, to select display 3, the corresponding value is 0, 0, 1, 0, okay, and you put into the positions of the register, so you will get 0x F9, 7, FF, and similarly to select fourth display 0011 is the input and the corresponding third output line will be activated. Okay, so thereby the corresponding value becomes 0x F9 FF. So these are all the different values should be forced via FIO pin register to select any one among the 4. Okay, and apart from these 4 values, if you force any other value, then that none of the register will be selected. Now let us look into the different values that are supposed to be written to FIO pin register to display a particular number in the 7 segment display. Suppose if you want to display 0, then a LED segment A, B, C, D, E, F should be activated and the LED G should be inactive. So Consider pin number 4 to 11, since these pins of port 0 are in turn connected to the segments of LED. So in order to activate A, B, C, D, E, F, the corresponding position of FIO pin register should be 1, whereas the remaining two positions, that is 10th and 11th pin of the FIO pin register should be 0. Okay, if you the corresponding hexadecimal value for this register position is 3F. Okay, so 0x3F is the value that must be returned to the FIO pin register to display 0. Similarly, 0x06 is the value that's supposed to be returned to the FIO pin register to display 1. Likewise, the different values that's supposed to be returned to the FIO pin register to display the hexadecimal number is listed here. The one point to be remembered is, if you write 0x3F, by default this 3F comes to the first 8 position of the register. That means this 0x3F corresponds to 0 to 7th position. But the pin position connected to 7 segment display LED starts from 4th bit to 11th. Therefore, every time when you want to write this value to the register, it is essential to shift this value 4 times to the left position. So you have to shift this value, that is whatever the value you listed here, this value must be shifted by 4 positions towards the left direction, and then this value has to be returned to the FIO pin register to match the corresponding pin position from 4 to 11. Okay, this is now let us look into the algorithm of the program. You have to identify the port pin. With the help of schematic, already you identify the port pin as pin number 4 to pin number 11 of port 0 to send a proper value to display a number on the 7 segment display, and similarly pin number 23rd to pin number 26th of port 1 to select any one display among the 4. These pins must be configured as general purpose input output pin. To configure the port 0th pin, we are going to use pin selection 0 register. Similarly, to configure 23rd to 26th pin of port 1, we have to use pin selection 3 register and force a proper value for this register to configure these pins as general purpose input output pins. After configure those pins as GPIO, set the direction of those pins as an output with the help of FIO DIR register, and you know how to set any general purpose input output pin as an output pin. And after set the direction of the pins, then you have to select one of the display among the 4. So the value to select a display among the 4 is discussed in the earlier slide. Here we are going to use a global constant. Here the global constant first underscore segment, or an object first underscore segment, is assigning a constant called 0xF87FFFF. So wherever in the program you use a first underscore segment, that is going to replace by a constant value. And after selecting a one of the display, then you have to send an appropriate value to display a number on 7 segment display. This is about the algorithm of the. Now let us look into the program. The first couple of lines of the statements, it include the header file. The one header file is lpc17xx.h, where all the associated register pertaining to lpc1768 are under lpc17xx.h header file. The next one is standard input output header file, and after that we have declared 5 global constant, namely first underscore segment, second underscore segment, third underscore segment, fourth underscore segment, and disable all. For this, a constant value is assigned. So whenever in the program we use first underscore segment, it is going to replace by a constant value, and these are to select any one display among the 4, and how this value existed is discussed in the earlier slides. Okay, if any value apart from these 4, all the 4 displays is going to disable. Okay, so that is corresponds to the disable underscore all value, constant value. Then we declared one integer, an unsigned integer digit 1, and initialized with 0 value, and also there is a declaration of an array which consists around 16 elements. So these elements of the array corresponds to the value that's supposed to be right on port 0th pin in order to display a proper number. So this is to display 0 and this value is to display 1. Likewise the last value is to display f, okay, hexadecimal digit f on the hexadecimal 7 segment display. And also unsigned long integer is declared, which reserves a 32 bit. Temp2 is an unsigned long integer where it initializes with 0. Similarly, another variable I is declared with initialization of 0. And there are two functions, a display function and the delay function. They are void function, they didn't return anything to the main program. Now initialization of the main program, where we are calling two system function. The one is this system initialization and system core clock update. They are two standard CMSIS functions in order to update the clock value. Then after that we have to configure the required pins as a general purpose input output pin, as we identified port 4 to port 11 of port 0 and pin 4 to pin 11 of port 0 and pin 23rd to pin 26th of port 1 are required. So those pins are going to configured as general purpose input output pin with the help of pin selection 0 register and pin selection 3 register. And this logical AND is performed in order to mask rest of the pins apart from the selected pin. So the rest of the pin configuration does not vary, so that in order to avoid the alteration of the other pins, we have to logically AND the corresponding values. Then set the direction of those pins as an output direction, and you have to perform logical OR operation in order to reserve the direction of the rest of the pins as it is. Okay, only the pins which are required, those pin direction has to be changed, and rest of the pins direction should not be affected. Okay, so this, what's the requirement of AND and OR is discussed in the earlier videos. Now we are dealing with the infinite loop while one, where here the indexing of the array is performed. Digit 1 is a variable, it's already stored 0. Now every time once this function or iteration is over, that value, the digit 1 variable will be incremented by 1. Okay, so now initially digit 1 is 0, and we are going to compare with 16 hexadecimal number value 10, that corresponds to decimal value 16. That indicates whether all the 16 elements in the array as displayed as a values in the 7 segment display, and for every iteration it's going to check with the value 16. If not, the iteration will be, that means the variable digit 1 will be incremented by 1. Once all the elements of the array is read over a particular port pin, again this digit 1 variable will be reset to 0. And after this iteration we are going to call a display function, and this is a delay function. Okay, so to create certain delay we are using a for loop. Then in display function we have to select a particular 7 segment display. So here with the help of FIO pin register we are going to select the first segment. The constant value of the first segment is declared as a global constant at the initial stage of the program. So by writing this value to the FIO pin, so that corresponds to the general purpose input output port pin once, because these values we need to read, or we need to write this value to the port 1, particular pins of the port 1. That's why the structure used is LPC_GPIO1. With the help of FIO pin register, this value has to be written onto the particular port pin, so that first display will be selected. Similarly, the digit 1 value will be 0 now, so the first element of the array will be assigned to a variable, temporary variable 2. Okay, assign a variable 2. Now this value of the temp2, a variable temp2, is left shift by 4 position. The requirement of the left shift is also discussed earlier. Since if you directly write this value via FIO pin, this will going to occupy the 0th bit of register, 0th bit of the pin position. Since our pin starts from 4th position, there is a requirement of left shifting towards left shifting of 4 bits. Okay, therefore so this instruction or this statement is very important. After left shifting to the 4th position, you have to we are going to write the value of the temp2 to the general purpose input output pin corresponds to 0th port via FIO pin register. Then we are calling the delay function, and those value will be going to clear with the help of FIO clear register. Okay, so this is about the program. And after reading the first element of the array, again your program control returns to the while one, that means return comes to this loop. Again the value of dig1 will be incremented by 1, and again it calls a display function, and those value will be supplied to the port pin with the help of FIO pin register. So this is going to execute infinitely. This is about the program flow. Okay. Thank you. The demonstration video will be attached at the end of the slide.